All right. Can you hear me? Yes? Okay. Let's get started. Hello, everyone. My name is Mete Atamel. I'm a developer advocate at Google, based in London, and today I'll be talking to you about Knative. Before I start my talk, I just want to point out that all my slides and all the codes that I'm going to show, they're already on GitHub. So if you go to GitHub, my username, knative-tutorial, and this is a QR code for that, it's already there. So you don't have to take pictures of anything except this page if you care about the slides or in the tutorial. And I want to do two announcements before I start my talk. First, we have a Google booth here. I don't know if you realize. Apparently, I heard that it's not marked or something. But feel free to visit the Google booth for project opportunities. If you have a startup, they have some startup information. If you want to Google Cloud credits, feel free. And I was told that in Poland, we actually have offices in Krakow and Warsaw. And there's some teams, like, for example, Google Kubernetes Engine, Google Compute Engine, with some positions. So if you're interested, I just want to point out that Google is present in Poland. And the second announcement I want to do is we have a program for startups. So if you're a startup, you can get credits for $3,000, $20,000, or $100,000 to run on Google Cloud. I always point this because I like to help startups. And this is the link for that. So if you go to this link, you can start with $3,000 credit if your startup is eligible. All right? So just two Google announcements. And now let's talk about Knative. So the way this talk is going to go is that first I'm going to do a little bit of introduction, just to make sure that everyone is on the same page and everyone knows about Kubernetes and Istio and what is Knative. And then after that, it will be very much demo-driven. I'm going to show some demos of how things work. So just hang in there for the first introduction, which shouldn't take too long. And then after that, we'll just look at some examples and see how this thing works. All right, so what is Knative? Knative, it's a Kubernetes-based open source building blocks for serverless. Anyone here using Kubernetes as a hobby project or in the production? So a few people. So you might be surprised at this point because there's nothing serverless about Kubernetes, right? I mean, especially if you set Kubernetes yourself, you know that it involves actual machines or it involves virtual machines, so that you have nodes, and you need to think about those nodes. You can't just treat Kubernetes as like this abstraction where you don't think about these machines behind the cluster. But that's the whole point of Knative. Knative allows you to treat Kubernetes as if there are no machines, and that's the whole point of Knative. Now, let's define what we mean by serverless, because depending on who you talk to, you get different definitions of serverless. On one hand, some people define serverless as just functions that get triggered by some events. On the other hand, any kind of service that you don't have to think about machines, people call that serverless. For me, there are certain things that I look at when I think about serverless. Number one, obviously, I shouldn't have to care about servers. I mean, obviously, there is servers somewhere, and someone has to maintain them and make sure that they're running, but it shouldn't be my problem if I'm using a serverless framework. Secondly, I want the serverless framework to be idiomatic. What I mean by that is, I am a C#.NET developer. I'm used to using ASP.NET Core Web API. I should be able to use that in my serverless framework. Similarly, if you're a Java developer, you're probably used to using Spring Boot. You probably want to use Spring Boot as well in your serverless platform. So you shouldn't have to reuse some special framework just to use the serverless library or framework. Thirdly, most of the time, when we talk about serverless, it's actually event-driven. So something triggers your function or something triggers your container rather than synchronous. And finally, you want your serverless framework to be portable. So let's say you deployed a serverless function or a serverless container to Google Cloud. Ideally, you should be able to take that and deploy it to Azure or on-prem or some other place, right? So when you look at Knative, actually it does a pretty good job of abstracting away servers, being idiomatic, being event-driven, and being portable as well. So hopefully at the end of this talk, you'll be convinced that it's a good open source project that will give you the ideal serverless framework that at least I look for when I look at serverless. Now, for those of you who don't know Kubernetes, I just want to cover this really briefly. So Kubernetes, it's all about scheduling and running containers at scale. So the idea in Kubernetes is that you deploy your code as a container. So you have a container image in a registry. Then from that, you create what's called a pod template. A pod is a single unit in Kubernetes that gets scheduled. Usually it's a single container, but if you have two correlated containers, you can schedule them together in a pod. Then you tell Kubernetes what you want to be true. In Kubernetes, there is this thing called replication controller, replica set. And here we are saying we want to have 3 replicas, so we want to have 3 copies of this pod running at all times. Then Kubernetes looks at the nodes that you have, either physical machines on-prem or virtual machines in the cloud. Then it finds the right places to schedule these pods, right? So scheduling now is not your problem, it's Kubernetes' problem. And once you have your pods running, you can attach labels to them. Once you attach labels, you can group them into what's called Kubernetes services. And the service has a stable virtual IP or a domain name, and people from outside will get to the service, will get to your pods, right? So in this containerized Kubernetes world, a microservice ends up being a combination of your code via the container and a combination of the building blocks that Kubernetes provides. Now, as application developers, we don't care. Or at least we shouldn't care, right? Because we have enough problems to deal with. So all these details about containers and scheduling and pods and everything, it's basically taking time away from what you want to do. As developers, application developers, we love serverless because it allows us to think about our code and nothing else. But at the same time, operators love Kubernetes because Kubernetes provides these building blocks and high-level APIs to manage containers at scale. So there's this tension between application developers and operators, because application developers, they don't want to care about Kubernetes, but operators want to use Kubernetes, and that's the whole point of Knative. Knative tries to bring these two worlds together so that we can still use Kubernetes, we can still rely on the building blocks of Kubernetes, but application developers running on Knative, they don't have to necessarily care about the fact that there's a Kubernetes cluster behind the scenes. So Knative project, it's open source, it's on GitHub. It was started by Google, but now a bunch of other companies like Red Hat and IBM, SAP, they're contributing. And you can think of Knative as a set of building blocks to turn Kubernetes into a serverless framework. These building blocks, there are 3 distinct building blocks: serving, eventing, and build, and we'll go through these as we go through the presentation. And actually here, I should also mention that Knative has its roots in Google Cloud. So if any of you use, for example, App Engine on Google Cloud, there are notions in App Engine such as versions. So in App Engine, when you deploy an app, you have multiple versions, and then you can do traffic splitting between those versions. Those ideas, they kind of made their way into Knative. So all the things that we kind of learned and used within Google, we are kind of moving some of that good best practices to Knative, and you'll see that as we go along. Now, the Knative stack kind of looks like this. So at the underlying layer, at the platform level, we have Kubernetes. Everything runs on Kubernetes. Then on top of that, Knative relies on a gateway. So Knative doesn't really solve the networking problem, right? So it doesn't really deal with the networking rules. It doesn't deal with how the clients get to your services. Instead, it relies on a gateway like Istio or Glue to do that. So Istio has been the default choice in Knative for the gateway. But starting in the latest version, which is 0.6, they added support for Glue as well as a gateway. I haven't used Glue, so I don't know much about it. But from what I hear, Glue is a lightweight gateway, so that's why some people prefer to use Glue instead of Istio. But the thing is that if you use Glue with Knative 0.6, it doesn't support eventing yet. So Knative eventing is not going to work. But I think going forward, Knative eventing will be supported in Glue as well. But just keep that in mind for now. Now, once you have the platform and the gateway, you then install Knative. And Knative has 3 components: build, serving, and eventing. You can install them one by one, or you can install them all at once. You can pick and choose what you need. So you don't have to use them all at once if you don't want to. And the idea is that on top of Knative, you have these products that are being built for developer experience. For example, on Google Cloud, there's something called Google Cloud Run, which is the managed version of Knative, or Google Cloud Run on GKE, which is the managed version of Knative on Google Kubernetes Engine. And there's other products from other companies that are being built on top of Knative. So the idea is that you will have Knative as the underlying platform for serverless, and then you will have different products on the cloud providers, from different cloud providers that will provide the further developer experience on top of Knative. And today's talk is all about Knative open source, so I'm going to show you how to install it as if you're installing it yourself. And all my examples, they work anywhere you have Kubernetes. But I will show a really simple example on Google Cloud Run so that you can see the difference between Knative open source and Google Cloud Run managed within Google Cloud. All right, so how do you get started with Knative? Well, first you need a Kubernetes cluster, and you also need Istio as the dependency of Knative. So depending on where you are, where you're running Kubernetes, there's different ways of getting a Kubernetes cluster, but on Google Cloud, you would basically run a single command, gcloud, and you will just say, create my cluster, and I am specifying an add-on that has Istio here, so this will give me a Kubernetes cluster with Istio already installed, and I'm doing some configuration with the machine types and the cluster location and stuff like that. But in the end, I will have a Kubernetes cluster. There's nothing special here. And then I need to create a cluster role binding. This is needed for Istio and Knative networking to work correctly, so I did it as well. And then I installed Knative. So Knative, the installation of Knative, it comes with YAML files that you can just point to and it will install it for you. So in this case, I am installing 0.6.0, and I'm pointing to serving, build, and eventing YAML files. So these are the YAML files that will install the full Knative for me. And that's it, really. So basically, get a Kubernetes cluster, make sure this Istio is installed, and make sure that you point to the right YAML files that you need for Knative. And in the end, what you're going to have, and I already did this before the talk, I have a cluster here in Google Kubernetes Engine. I already did all this work. So I just want to make sure that things are running. So what happens with Knative is that it installs the Knative eventing, serving, and build into separate namespaces. So if I look at the pods of, let's say, serving, I just want to make sure that they're running, and they are. And let's look at the eventing pods. Those are running as well. And then finally, build, those are running as well. So all of Knative is running for me, which is a good sign for demos that I'm going to show you later. All right. Now, let's first talk about Knative serving, the first part of Knative. Now, what is Knative serving? The way I describe Knative serving is that it enables you to deploy a container in a serverless way, right? And what I mean by that is you create what's called a Knative service. You point to your container image in a public repository, and you tell Knative, just create this for me. And what Knative does is that it deploys your container. It sets up the networking to your container so people can get to your container from external of your cluster. And it just runs your container, just like that. Then on top of that, you have automatic scaling. So your container will run in a single pod, but it will scale down to 0 if no one uses it for 60 seconds. And it will scale up to n that you can define. And then every time you deploy a container, it has a configuration. And when you deploy it, you get a new revision, right? When you deploy your container again, for example, it will get a new revision. So you have this configuration and revision management. And since you have multiple revisions, you can do traffic splitting between those revisions. So by default, the latest version that you deployed will get all the traffic. But if you want to do something smart, like maybe the latest version gets 50% of the traffic, but the previous version gets the other 50, you can set that up as well. So basically, it enables you to deploy a container and get networking set up, get automatic scaling set up, get configuration and revision management, and get traffic splitting if you want. So the Knative serving primitives are kind of like this. At the top level, you have Knative Service. Just note that this is not a Kubernetes service. In Kubernetes, there's also services, but this is separate. This is under Knative API. So you create a Knative service. The service will have a configuration that you define that points to the image, and it has things like the environment variables. And then you deploy your service. As soon as you deploy your service, a revision will be created for your service, and a route will also be created that will point to that revision. So by default, the revision gets all the traffic. If you make any change in the configuration and deploy again, it will create a new revision, and the route will be updated to point to that revision. Or you can change the traffic rules in the middle so that you can do 50% traffic splitting if you want. But the primitives of Knative serving is the Knative service, configuration, revision, and route. So let's take a look at this. As I mentioned, all my samples and all my slides are in this Knative tutorial, and I'm going to refer to this tutorial as we go along. So I just want to do a really simple Hello World application and see what it takes to actually build that. This app, it's a very simple app that kind of gets a request, and it will just say hello, hello world. I wrote it in C#, but that's almost irrelevant. I mean, any language you can use. I created my sample. I pushed to Docker Hub, and I call it hello world v1, version 1 of my application. Then I need to create a Knative Service definition, right? So I have this service YAML file, and you will realize that at the top I have API version that points to Knative API, and the type is service, the name is hello world, and the namespace that this will be installed is default namespace. And then under here, I define some things about my service. So this is the configuration. The first thing that you will realize is that I have this thing called run latest. What this means is that when I deploy this service, it will get 100% of the traffic, right? So that's what I want. And then the configuration points to the image that I pushed earlier, and it also has some environment variables, name, target, and the value is v1. And what my code does is that it will read this environment variable and it will print it out. So it will say hello v1. So I create the service, and then I watch the pods, the Knative service, the Knative configuration, the Knative revision, and the route. So let's do this and see what happens. So first, let me just watch these things. And you'll realize that I already have some pods running. These are pods that I set up for my eventing samples that I'm going to show you later, because it takes them a little bit of time to set them up, but you can ignore them for now. But here I'm in hello world, and I have my service definition file, so I'll just apply that. So now the Knative service is being created, and if you look at here, you see that a Knative service called hello world is created, the configuration is created, the revision, the first revision is being created, and a route that points to that revision is being created. So everything is created, and my pod is also created by Knative and it's running. So everything is up and running. But how do I get to this service? Well, I had to go through Istio, because Istio is the one managing traffic to my cluster. And in Istio, there's something called Istio Ingress that has a public IP, and everything goes through Istio Ingress. So I find the Istio Ingress IP, and then I can do a curl to that IP like this. But I need to specify which service in which namespace is that I want to get to. So in this case, my service name is hello world, and the namespace is default, and example.com is the dummy domain that comes with Knative. So I'm basically curling this Istio Ingress IP, and I'm specifying my service and the namespace. Now, this is how you will get to it if you haven't set up your own domain. But I also show in my tutorial how you set up your own domain. I won't bore you with the details, but you can read it here if you want. For this demo, what I did is I used something called nip.io. Nip.io, it's a dummy domain service that lets you map URLs like this, so domain names like this to IP addresses like that. So I use that so that I don't have to set up domain myself. So I set up nip.io with my app, and by doing that, I can do a curl as if I have a domain name, right? So let's curl this actually and see if our app is running. One thing you realize, our pod is terminating. The reason is we haven't used it for 60 seconds, so it's scaling down to 0. So if I do a curl again, if everything works, now it will try to spin up a new one. So you can see it's container creating, and now it's saying hello v1. So it's actually the new container that was just created that's handling my request. So you can see that by just deploying a Knative service, I have all the underlying things that I need set up, and I can already curl to it if I set up my domain correctly. Now, as I mentioned, every time you change the configuration, you get a new revision, right? So let's just review again. So every time I change anything in here, it will create a new revision, and it will update the route. So let's take a look at that. For example, in here, I'm updating my service definition, and I'm saying I'm using the same image again. It's version 1, but I'm changing the environment variable and target value to v2. So I'm changing the environment variable on my configuration. So let's do that. And then what you're going to realize is that it immediately created a new revision. This is generation 2. And it created a new pod for the new revision. And if we do a curl again, you see that hello v2. So we updated our service with the new configuration. Now, if you want to change your code, it's the same way. Instead of pointing to the environment variable, now what you need to do is, for example, let's say instead of saying hello, if you want to say bye, I change my code. I create a new Docker image and push it to Docker Hub. So in this case, I'm calling it hello world v3, the version 3 of my application. Then I come to my service, and I change the image from version 1 to version 3. and that's how I would update my code. So if I apply this, service v3, you see that it will create a new revision, and it will create a new container just like before. And when that container is up and running, if we do a curl again, now it says by v3. So we updated our code from hello to by. So that's how you can easily update your code. But of course, in real world, you wouldn't update code like this. In real world, what you would do is that you would deploy a new version of your code and maybe let it get 10 or 20% of the traffic, make sure it works, and then do an update to 100%, right? So you want to do a rolling update, or you want to do red-green deployments, whatever you want to call it. In Knative, this is very easy to do. So in this traffic splitting section, I talk about that. So what you need to do is you go to your service definition file, and instead of doing run latest, you need to do a release, right? And in release, you need to point to some revisions. So what I'm doing here is that I'm pointing to revision 1. This is the revision that exists already. And I'm pointing to a new revision, revision 4, that I'm going to create right now. And I also specify a rollout percent, in this case 20. So what this means is that the existing revision will get 80% of the traffic, the new version will get 20% of the traffic. And this configuration here is for the revision that I'm creating. So it's using the same image, except the value of the environment variable is v4. So let's apply this, service v4. And one thing that I forgot is that when you look at our service definitions, when you look at the revision numbers, the generations are 1, 2, 3, 4, but the actual revision names, they have hash codes. So I need to actually use those hash codes in my definition. So let me just copy, this is for version 1. Let me just change this 001 with the actual name. And then for the fourth one, let's copy this one. All right, and then let's apply again. Now this will create the version 4, or update the version 4, and then it will do the traffic splitting, 80% to version 1, 20% to version 4. And let's do some curl commands. Let's do a curl within a loop. So here I'm just doing the same curl, but I'm doing it within a loop. So let's do it 10 times. I got hello v4, hello v4. Now it's hitting v1, so it's creating the v1 because it scaled down to 0. Now it's v1, v1. So most of the time, it should be v1. I mean, right now it's like almost 50-50, but most of the time, over time, if you run it again, you will see that it will be v1, and once in a while it will be v4 because we did 80% to 20%. So that's how you can do traffic splitting between an existing revision and a new revision. If you want to do traffic splitting between 2 existing revisions that already exist, it's very easy. You just do the same thing as release, but in here, in the revisions, you just point to the revisions that already exist, and anything under configuration will be ignored. This is a little bit confusing, by the way, because in here, for example, we are deploying to existing revisions, but the configuration doesn't matter in this case because we are not creating a new revision. So it's a little bit confusing, but they changed the API recently, and they made this a little bit more clear. I'm going to update my tutorial with those examples so that it's clear to people as well. All right, and as I mentioned, this auto-scaling, scaling down to 0 and scaling up, it's all configurable. What I want to do is let me actually deploy a service, a new service. It's called a sleeping service. Basically, when it gets a request, it just sleeps for 4 seconds, like simulating work, and then it will reply back with hello world. And the reason why I'm creating this sleeping service is that I want to set auto-scaling to really low, hit the service, and see that it actually auto-scales. So let me start that now, and then I can show you the configuration for auto-scaling. So let's just go to sleeping service, kubectl. Well, first of all, let me get rid of my other Knative services. So if I do this, I got rid of my hello world service. And now let's apply the sleeping service. So you'll see that it will be immediately created. And as the sleeping service is running, let me send some load to the service, make sure that we can scale it out. So I'm going to use a tool called Fortio for load testing. So I'm just sending some load to my sleeping service. Now, as that's scaling up, and as you can see, sleeping service right now, it has a single pod, right? Hopefully, when I come back, we'll see more pods. But the way auto-scaling works is that basically you go to your service, under metadata, you have some annotations for auto-scaling. So by default, this is what you have. You have concurrency-based auto-scaling. meaning each pod by default will get 100 requests per second. So now the target for sleeping service is 1. I scale it down to 1 so that I can show you auto-scaling. But by default, this is 100. So every time a pod gets 100 requests, it will handle those 100 requests. But on 101, it will create a second pod. Now, this auto-scaling can be changed. So if you want CPU-based auto-scaling, you can just comment that out and add this in. And this will switch to CPU-based auto-scaling. The min scale and the max scale are configurable. So by default, min scale is 0, meaning it scales down to 0. But in this case, I'm setting my minimum scale to 1. So I will always have a single sleeping service running. And you should also set a max scale because you don't want things to auto-scale infinitely. So in this case, I'm setting it to 5. So I will have 5 maximum pods running for sleeping service. By the way, you can also write your own autoscaler and hook up to your code here as well. So that's also totally configurable. So let's see what happened with our service. So if we go back here, you can see that sleeping service is like now we have 5 pods running. So yeah, auto-scaling seems to work. So let me just kill this. And then we'll see that it will scale down to 1 pretty soon. So that's how you can configure auto-scaling. And Knative, I mean, you can integrate Knative with anything, really, because at the end of the day, you have an endpoint that has a public URL. So anyone who can call that endpoint can actually be integrated with Knative. So in this case, for example, I wanted to play with Twilio. Here, do people use Twilio or heard of Twilio before? Anyone? A few people, yeah. So Twilio is a really cool service library, whatever you want to call it, for writing phone-based or SMS-based application. So what you can do in Twilio is that you can go to their website, sign up for a trial. At least in the UK, you can get a phone number for free. So this is my phone number. And by the way, feel free to call this number, because if you do, I won't be answering. It will be Knative who's going to be answering. But what you can do is that this is my number. And you can say, OK, if someone calls me on this number, make a call to this endpoint. So in this case, I haven't changed the default endpoint, so it will go to the Twilio's phone handling. But I changed the messaging. So if someone sends me an SMS message, it will make a call to my Knative endpoint. So this endpoint is a Twilio service /SMS will handle the SMS messages. So let me deploy that service first. So I go to Twilio. Let me first delete my existing services, because I don't want them to clutter the space. And then let's apply the Twilio service. So this creates the Twilio service. And just to show you the code briefly, so this is again C#, but you can do this in any language you want. So I created a really simple app, and then I created an SMS controller. So if someone goes to /SMS, it will get here. I'm using the Twilio libraries for C#, and then I say, if someone calls this endpoint, I get an SMS request, and I want to create a response. So that's my response back to the user, and I will just say the Knative copycat says, and echo back the message. So I basically get a message and just say Knative copycat says, and just echo back the message. It's very simple, but it just shows how you can integrate with Twilio. So I created a Docker file. And then I push my image to Docker Hub. This time I call my image Twilio. And then the service YAML file, it's just like before, except I'm pointing to the image that I just pushed. And then I go to Twilio console and point to my public URL for my service. So if this worked, let's see. So I have my Twilio running, and I have my minimum scale at 1, so it will always keep running. Then let's go to my messages. So here I am in Android for web. So you're looking at SMS messages on my phone. And this Mete Twilio is my Twilio number that I'm going to send the message to. As you can see, every time I go to a conference, I use this. So the last one was in Oslo. But here, let's just say, hello from Krakow, Devoxx Poland. So I'm sending a message from my phone to Twilio number. Twilio number will say, OK, I'll call this Knative endpoint. And the Knative endpoint will wake up my pod, and pod will respond back, hopefully, as it did already. The Knative copycat says, hello from Krakow, Devoxx Poland. So you can see that it's quite easy to integrate with anything that can call your endpoint with Knative. All right, so that was this, basically. And now what I want to mention is that so far what we looked at is Knative everywhere. So all of this will work anytime you have Kubernetes. It doesn't matter where the Kubernetes is running, so it will work as long as you install Knative and Istio. But if you're on Google Cloud already, you wouldn't use Knative as is. You wouldn't install it yourself. Instead, you will use something called Quadrant. So Quadrant, it's a managed version of Knative, and it basically makes it really easy to use Knative features within Google Cloud Run. There's two versions, the fully managed version 1, Cloud Run, or if you want to stay on Kubernetes, there's a Cloud Run on GKE version. It's basically the same thing, but you're running on a Kubernetes cluster if you want to stay on Kubernetes. So I just want to briefly show you the Cloud Run one so that you get an idea of how the developer experience works on Google Cloud. So what you need to do for Cloud Run is that, first of all, Cloud Run was just announced like last month or maybe a couple months ago, and it's only available on US Central 1 region, but it will be available on all other regions very soon. So first, I need to switch my project to a project in the US. So let me do that before I forget. So that's my project in the US. And then Cloud Run doesn't support Docker Hub yet, but instead, what you can do is you can push your image to Google Container Registry, which is kind of like Docker Hub, but it is within Google Cloud, within your Google Cloud project. So here, when you use gcloud command line tool, you can say gcloud build submit and tag your image, and you just say GCR project ID hello world v1. So what this does is it basically takes your Docker file, brings it to the cloud, and it builds it in the cloud, and it saves it in Google Container Registry, right? So I already did that, and once you do that, all you need to do is just run a single command. Where is it? Yes. So what I'll do here is I'll just say gcloud beta run deploy. So this says deploy this image that I'm pointing to Cloud Run. And I just need to change my project ID to my actual project ID. So I'll just do Cloud Run Atamel. And let's see what happens. So it tells me what's the service name, hello world, because I deployed this before. And now it's deploying it. So it's creating a revision, just like Knative, and it's routing traffic to that revision, just like Knative. But one difference in here is that I haven't created any clusters. I haven't created any, I haven't installed any Istio. I haven't configured any domains, nothing. I just said deploy this image. And then what happens is that in the end, if I go to Google Cloud Console, and if I switch my project to US project, and under here, I have Cloud Run section. Now you can see that I have a bunch of services already installed, but this hello world one is the one that I just deployed. So what you do is you get some metrics. I mean, I just deployed it, so no one is using my service yet, but if they did, you would see it here. Under revisions, you see all the revisions of your service. So this 009 is with 100% traffic, was deployed just now, so it's the one that we just deployed. And I can see the logs from here, and yeah, once it loads, but we won't wait for that. And then the details. So this is an unauthenticated service, meaning anyone can get to this. I also get a default URL for my service, so domain is already set up for me, but you can also hook up your own domain into this. So if I click into this, it's the same exciting hello world v1, but it's running on Cloud Run. So the experience is very much like Knative, except you don't have to worry about the underlying details of a cluster. It's fully managed. All right, that's all I want to show you in terms of Cloud Run. So let me switch back to my other project and go back here and do the same before I forget, because one time I forgot and it was a disaster afterwards. All right, we are back and we can kill this. All right, I have 15 minutes, so that's good time for eventing. So everything I showed so far was Knative serving. Now let's look at the next part of Knative, which is eventing. So eventing, in a nutshell, allows you to connect some event sources to some event consumers with some kind of flow in the middle. That's the easiest way I can explain it. The event consumers are basically Knative services, and the event sources can be a lot of different things. So this is some of examples of event sources. For example, you can listen Apache Kafka messages, you can listen Google Cloud PubSub messages, you can listen GitHub events, or Kubernetes events, or Google Cloud Storage events, and so on and so forth. The full list is here. This is not the full list. But the way it works is that first, in Knative, you have these things called sources. These are, I think they are misnamed. They should be called source importers, actually, because they are the ones that are listening for external events and importing them into Knative, basically. So you get the events into Knative, and these events are different types of events, like GitHub and Kubernetes and stuff like that, but they eventually go to something called broker. So usually you will have a single broker running in a namespace, and the broker is the one that will receive the messages from the sources. Then broker will pass those messages to a Knative service, but in the middle there's something called trigger. A trigger it's a thing that kind of combines the messages from broker to a service, but with some filtering in the middle. So if you want to filter, for example, if you want this service to only get read messages, you can do some filtering in the trigger, and then the broker will basically just pass in those only that kind of messages to that service. I should also mention that all these messages that come into Knative, they're all different types of messages, right? But what happens is that at the source layer, once we have these sources reading all these messages, they will convert these messages into what's called CLUD events. CLUD event is an open source event definition from CNCF. And in CLUD event, you will have some metadata for your events, and the actual data of the CLUD event will have the actual event that you're listening. So in this case, for example, the GitHub event will have the GitHub payload in the data. So the broker will only receive CLUD events, basically. And then the broker, we already mentioned, it's one per namespace. Then it goes to a trigger, where in the trigger you can do some kind of filtering if you want for the type of messages that you want to filter. And then you have a subscriber, which is basically a Knative service that's defined. And that's it, really. Then from then on, your service will keep receiving the messages. Let me show you an example of this. First, let me point out that I have a Hello World eventing example. I will skip this because it's not that interesting, but it actually shows you how to set it up initially. And so it's useful if you want to understand how it works. But what you need to do is basically, you need to make sure that Knative eventing is installed, and then you need to set a source. So in this case, I want to read PubSub messages from Google Cloud. So I set up a Google Cloud GCP PubSub source. And you also want to create a broker in your namespace, right? So a source and a broker has to be set up before you do anything. And then after that, I create a C# example, and I receive the PubSub messages, and I just log them out, right? But I will skip this one. I just want to make sure that my sources are set up. So let's just do kubectl get PubSub source. Yeah, so I have a testing source that's already listening for messages, and I also want to make sure that the broker is running. So the broker in the default namespace is running. So I'm set up for any kind of example in my default namespace. But the example that I want to show you is a Vision API example. So I have another one for translation API that you can read if you want. But the Vision API, what I want to do is something like this. So in Google Cloud, there is something called Google Cloud Storage. It's a place where you create a bucket, and in the bucket you can save any kind of file you want. And what you can do is you can also enable notifications on the bucket. So you can say, when someone saves an image in this bucket, trigger a PubSub message, right? So what I did is I created a bucket. I say, if someone saves an image, send a message to this topic. And then I set up Knative to listen the topic. So the message will go to Knative eventing. And then the Knative eventing will pass it to a Knative service. And the Knative service will get the CLUD event that has the information about the image that's been saved, and it will make a call to a Vision API. Vision API is a machine learning API that can detect images, and it will tell you the labels in that image using machine learning. So what I'm doing here essentially is I'm connecting the Google Cloud storage events to a Vision API, to unrelated services using Knative in the middle. And the key thing here is that everything right now runs in Google Cloud, but this Knative part can run anywhere, right? So it doesn't have to be in Google Cloud. So to set this up, I created my code. So let me just briefly show you how that looks. So this is, again, C#, but it can be in any language. First thing I need to do is, as I mentioned, the events get changed to CLUD event, right? So eventually my service will get a CLUD event. So I'm basically parsing the CLUD event. And then in my code, I am looking at certain event types. So when you save an image, the cloud event type will be object finalized, right? And those are the only event types that I'm interested in. Then from the actual cloud event, I extract the bucket ID and the object ID on my image. So I'm basically figuring out where my image lives. And then I create a Vision client. So this is the client that I'm going to use to make a call to Vision API. And then I just say Vision client detect labels async. So this will make a call to Vision API and extract the labels from the image at this URL. And as a result, I'm getting 10 results back. And each label will have a score. I order the scores from highest to lowest, and I just log them out, right? So that's what my code does. And then after that, I build my image, and then I create a trigger.yaml file. So in this trigger.yaml file, I have two things. First, my Knative Service. So this Knative Service it's a Vision. It points to my Vision code. And then the second one is trigger. So this trigger, it does basically just the connection from the broker to my service. It doesn't do any kind of filtering. So any kind of message will trigger this service, and it will eventually go to my Vision service that I just defined up here. So let's do this and see what happens. So go to eventing and Vision, and I will just apply kubectl trigger. And then you can see that my service, Vision service and trigger is created. So if I do get kubectl get trigger, I should see a Vision trigger. And if I do get pods, I should see a pod for Vision as well, right? So the container has been created. So once that works, yeah, it's running right now. Now it's ready to receive traffic. So let's look at the logs of this service. So what I do here is that I create my bucket. I enable notifications on my bucket. And then let me look at the logs on my service. So this is how I would do it. Logs, and then get the log ID. You can see that it's just listening on port 8080, right? It's just waiting for messages. Now what I need to do is I need to save an image to the bucket. So to do that, I go to Google Cloud Console, and then I go to storage. So this is Google Cloud Storage. I already have a bucket named Knative bucket, where I enabled the notifications, and I'm just going to upload a file. So let's go here, eventing Vision, pictures, and I'm passing this image. I don't know if you can see it, but basically, it's like a beach with sunset and mountains. So I'm saving this image to Cloud Storage bucket that will trigger a message to PubSub. PubSub message will be listened by Knative. Knative source will get it. It will pass it to broker. From the broker, it will go to the Vision service. That will make a Vision API call. And in the end, if everything worked, let's see. Yeah, so you see that our service received the content, and the data is base64 encoded. It has the basically cloud event. And then we extracted the cloud event and make a call to Vision API, and then it says now the picture is labeled sky, body of water, sea, nature, coast, water. So it extracted these labels from the image, right? Cool. So that was a quick example of what sort of things you can do with Knative. Now in the last 5 minutes, we'll go through build really quickly. But before we go through build, I want to kick some builds, and then we'll talk about build, and then we'll come back to the builds just to show that it actually worked. So what I'm going to do is go back to my console, and first of all, let's delete our Knative services. We don't need them anymore. I go to build, and then here I have a bunch of builds. So I'm going to kick a build to build hello world .gcr. So this will build and push to Google Container Registry, build an image. Another one is Docker. So this will build and push to Docker Hub. Another one will use a build template with Canico, and it will build using Canico and push to Google Container Registry. And then let's do one last one. Build template, use build pack, and build a Java app and push it to Google Container Registry. So if we look at the builds, if I do kubectl get build, you see that I have 4 builds that are pending, meaning they're kind of being worked on. And if I do look at pods, you see that there are some pods that are being initialized that will do the build for me, right? Now, what can you do with build? It basically allows you to go from your source code to a container image on a repository. That's all there is to it. It gives you some primitives to work with. So first, you have the build object. This is basically one or more steps that you define that will be executed in order. You have what's called build template. So you can take your build and make a template out of it so that you can use it for multiple builds. Or you can install someone else's templates and just use it from your builds as well. You have different builders for different things like building containers and other things. And finally, you have something called service accounts to authenticate. For example, when you want to push to Docker Hub, you need to be authenticated. So for that, you will need to use a service account. So let me show you the definitions of my builds so you get an idea what's involved. I'm here, actually. Yes, hello, build. So for example, in this case, I have a build that points to my source. So it points to my Knative tutorial. And then I have my steps. And I only have one step that's build and push that will use Canico. Again, Canico is an open source project to build images. So it will use that image to build my own Docker file. I point to my Docker file, and I point to my destination. And in this destination, I'm saying gcr.io, and the project ID is going to be my project ID, and I'm tagging it with this. So what this will do is it will create a pod. That pod will build my Docker file and push it to Google Container Registry. And as I mentioned, you can do get build and get post to see that. And in the end, you can see when it's completed, you will get a completed status, right? So this is to Google Container Registry, which doesn't require authentication. But in Docker Hub, you need to be authenticated. So what you need to do is you need to create a secret with your Docker Hub username and password, base64 encoded. So this is a Kubernetes construct. And then you need to create a service account, again in Kubernetes, to point to that secret. So here I create a service account, give it a name, and I point to my secret that I just created. And then in your build, everything is the same, except I refer to a service account. So this is a service account that will authenticate with Docker Hub. And the destination points to docker.io instead of gcr.io. So that's how you can push to Docker Hub. And normally, you wouldn't do builds like this. Instead, you would rely on a build template to do the builds. For example, I'm using Canico, and Canico has a build template. So what I can do is I can install the Canico build template like this. And then if I do kubectl get build template, I'll see what templates I have. And then when I am designing my build, it's the same. Again, I'm pointing to my source. But instead of steps, instead of defining the steps myself, I just point to my Canico template and just provides the arguments for the template. So in this case, the Canico requires the image, where you want to push this image, basically. So I'm pointing to GCR again. So that's how you would use a template. And finally, I love build packs. Anyone here knows or uses build packs? They're basically a way to build images without having to define Docker files. Because creating a Docker file, an optimized Docker file, it's not that easy, actually. You can have a hello world Docker file, that's easy. But if you want to optimize it and make sure it's small and secure and all that kind of stuff, it takes a lot of effort. And I'm not a Docker expert in any way. Instead, you can use something called build packs. It's an open source project that will look at your code, and it will create a Docker file for you from your code. Thankfully, there is a template in Knative for that, so you can install the build pack template. And then once you do that, in your build, you point to your source again, and then you point to your build pack template, and then you just say, this is where I want to push. But what this does is that if you go to this URL, it's a sample Java app. It doesn't have a Docker file. It will look at your code, and it will figure out the right Docker file for it, and it will just push it to the place that you specified. All right, I'm out of time, but last thing that I want to show is let's just take a look at the builds and see if they worked. Build, yeah, they're all succeeded. And I'll just take a quick look at one of them. So if I go here, Google Cloud, Container Registry, and under images, let's look at the Hello World one. You can see that this 1 minute ago, this is the Hello World build, and this is the one that was built by Canico template. All right? So that's all I have. If you want to get the slides and the code, Knative tutorial, and this is the QR code. Knative has a new website, knative.dev, so feel free to go there with much more information. And I'll try to hang out at the Google booth later. So if you have any questions, feel free to find me right here or at the Google booth later. So thanks very much.